Alright, 12.4, surface area of cylinders. Students will be able to find lateral and surface areas of cylinders. Alright, so we got some basic qualifications of a cylinder. So I got a circle as a base. So here's the base, here's the axis, here's the altitude. Also, if it's a right cylinder. If it's an oblique cylinder, the altitude's still going to go perpendicular to the bases, but the axis is going to be parallel to the sides. Alright, well, what is the lateral area of a cylinder? Well, if we wanted to find the lateral area of a cylinder, if we were to imagine unrolling this cylinder, it would create a rectangle. And the base of that rectangle would be the circumference of the cylinder. So the circumference is 2 pi r. And if we do base times height, we would just do 2 pi r times height. And that's it. That's the lateral area. So we got this problem here. It says an office has recycling barrels for cans and paper. The barrels are cylindrical with cardboard sides and plastic lids and bases. Next part of the problem is on the next page. Each is 3 feet tall and the diameter is 30 inches. How many square feet of cardboard is used to make each barrel? Sorry about the little spillover of the question. Let's put the formula here again. Okay, well, let's kind of just sketch this real quick. Let's say this is my barrel. Okay. And this is 3 feet tall. And there's my diameter, which is 30 inches. Hopefully right away you'll see there's something wrong with the information they give us. Some of it's in feet and some of it's in inches. We need to work with all one unit in order for any of our formulas to work. So they want us to go to square feet, so let's convert this to feet. Well, 30 inches, how much is that in feet? Well, I just kind of can do this in my head. I think you should be able to do that too. You know that 1 foot is 12 inches, 2 feet is 24 inches, and you'd have 6 inches left over, which is half of a foot. So 30 inches is the same thing as 2.5 feet. So now we're ready to plug it into our formula. Well, let me zoom in so I can write it all down. We know that the lateral area equals 2 times pi times the radius. Well, let's think here. They only told us that this was the diameter, so the radius is going to be half of that. Well, half of 2.5 is 1.25. So 1.25. And then times the height. Well, the height is 3 feet, so 3. And to simplify this, I always just put the pi at the end now, once I got all my numbers in. So I'm going to have 2 times 1.25 times 3 times pi, and this will give us feet squared. Well, 2 times 1.25 just puts us back at 2.5. And 2.5 times 3 is 7.5. So we have 7.5 pi feet squared. Now that answer would be enough if they asked for it in exact terms. If not, we can always plug in our calculator and see what we get. And this would be approximately 23.6 feet squared. Alright, there's how you find the lateral area. Now, let's think about this. If we were going to find the surface area, well, wouldn't that just be the lateral area, so the rectangle shape around the cone, or around the cylinder, I mean, plus the circle on top and the circle on bottom. So we could say surface area equals the lateral area, which is 2 pi RH, plus the 2 circles on top and bottom, so 2 times pi r squared, because that's the formula of a circle. So let's just see what this would look like if we were plugging into this next problem. It says T equals 2 pi. My radius, the radius is 8.3 times a height of 6.6 plus 2 pi, right, the radius again is 8.3, and we square it this time. Okay, well, we could do this kind of a step at a time. or we could put the whole thing in our calculator. If you want to put the whole thing in your calculator and see if you got it, that's fine, but I'm going to break it down to one step at a time so that we can kind of all make sure we're on the same page here. So the first thing I'm going to do is I'm going to do 8.3 times 6.6, and we should get 54.78 plus 2 pi, and let's see what 8.3 is squared. 68.89. And now we're multiplying both of those by 2 and by pi, so let's just do by 2 here. So this would be 137.78 pi, and 54.78 times 2 is 109.56 pi. And now we actually could add those two together, 109.56 plus 137.78, because they are like terms. And this would equal 247.34 pi. And that could be your final answer, as long as you put feet squared. But let's just see what it is when we actually multiply it by pi. So, well, when you multiply it by pi, I end up with 777.04 feet squared. Sorry, I kind of got out of order there. So I've plugged it in, simplified. I got 247.34 pi, and then I just multiplied this by pi on my calculator. I got 77.04. That's example number 2. Okay. This one, example number 3, this is a really fun one. This one they say, find the radius to the base of a right cylinder if the surface area is 128. So we're asking for area there. Is 128 pi centimeters squared, and the height is 12. So they're going to give us the surface area, and they're going to give us the height, and we're going to have to solve for the radius. Well, right away, hopefully you see this is an r, and this is an r squared, and we're going to have to solve for an r squared, which means this is a quadratic equation. So let's set it up. First thing I like to do is just write the formula again. So let's write it all out here. You got T equals 2 pi RH plus 2 pi r squared. And now let's plug in what we know. Well, we know that the total surface area is 128, right? So let's plug that in. Or 128 pi, I should say. And that equals 2 pi r. We're also going to plug in the h, which we know is 12, plus 2 pi r squared. We could simplify this all a little bit. The 128 pi, nothing really happens to that, so we just leave it as 128 pi. 2 times 12, though, that's 24 pi r plus 2 pi r squared. And I said at the beginning, this is a quadratic, so whenever we have a quadratic, we need to set it equal to 0. We do that by subtracting 128 pi from both sides. And you end up with 0 equals. And now let's go ahead and put it in order. R squared, then r, and then our c term. So it would be like this. 2 pi r squared plus 24 pi r minus 128. I swear that's an 8 pi. And now we have to see if there's anything we can factor out. We can factor out, let's see, I have a pi in every single term. And I have a 2, 24 can take out a 2, and 128 can take out a 2. So I can actually take out a 2 and a pi in every single term. So let's do that. And I even have to do it to the 0. Okay, well 0 divided by 2 pi is still just 0 here. The 2 pi's cancel out, and I just have an r squared plus, here the pi's cancel out, and this makes a 12, so I'm just going to have a 12r, and here the pi's cancel out, and 128 divided by 2 is negative 64. Okay. I'm going to rewrite this equation up top here. 0 equals r squared plus 12r minus 64. Let's just check, make sure that's the same thing. Yeah, because I just need a little bit more time. Okay, at this point, I've told you guys to always check and see if you can factor it before you use the quadratic, because factoring is just a lot easier than using the quadratic formula. So, let's make our little factor tree. Negative 64 on top, 12 on bottom. I'm looking for something to multiply up to that, add up to that. So I've done this a few times. You may want to pause and see if you could figure out what 2 numbers do this, if you haven't done this already. But if you think about it, you end up with 16 and negative 4. So 16 times negative 4 is negative 64, and 16 plus negative 4 is 12. So that means we can rewrite this equation as r plus 16 times r minus 4. And that means the 2 numbers we could plug into this equation that would make the whole thing 0 is when r equals negative 16 and when r equals positive 4. Now the problem with this is we're solving for the radius of a cylinder, and can the radius of a cylinder be negative? Well, it cannot. We can't have a negative distance, therefore the radius is just 4 is the final answer. There you go. See you guys on the 12.5 video.